Hello everyone. Today in this video we will be covering the first section of the chapter of infrared spectroscopy. Now infrared spectroscopy is an analytical technique that is used by professional chemists to separate, purify and primarily identify the analytics of an organic compound. Now organic compounds, what we mean by that is that the functional groups present in the organic compounds are identified by various factors. We will be discussing that in later slides. But for now, let us understand the functionality behind which an infrared spectroscope is able to work. Now, for example, you have any organic compound over here, okay? And it is any unknown organic compound. What happens is that when light is struck on this organic compound, it absorbs certain wavelengths of light in the infrared region and it transmits other wavelengths. And due to this, an infrared spectrum is formed. And this infrared spectrum is shown graphically, which we will be discussing in a while. Now, some frequencies or wavelengths are absorbed by the organic compound, right? And so this is shown by a detector which shows the percentage transmittance of light that passes through the compound, okay? Now, before we go into that, let's work out some of the things that we have mentioned over here. Wave number is basically the inverse of wavelength, okay? And wavelength is a concept that we have covered in O-level physics. It is basically the length of a single wave from one crest to another crest, right? And so on. So wave number is the inverse of a wavelength and the units are centimeters to the power of -1. You need to know this. Now, another thing that is in the syllabus is the relation between energy and wavelength. The relationship is inverse. Energy is inversely related to wavelength. How do we know this? We don't know this actually, because the details of this are derived from the Planck's constant, which is way beyond the scope of our syllabus. So we do not need to know where this relation came from. You only need to revise it as it is. Okay, so energy is inversely related with wavelength. So that means if we have high energy, we should have shorter wavelengths absorbed, and if we have low energy, the opposite should happen, longer wavelengths absorbed, right? So this is what we are trying to aim for, that this is what the effect of energy has on the wavelength. Okay, now let's look at the IR spectrum. This is the graph that is going to be made. This is the graph that is represented by the data that we get from the detector. Okay, now on the x-axis we have wave number. Okay, so on the x-axis we have wave number, which is always labeled from 500 to 4000. Okay, and it is always labeled in a descending order. It starts from 4000 and it goes till 500, and the units are centimeters -1. On the y-axis we have percentage absorbance or percentage transmittance. Any can be there, it depends. Okay, now we mentioned that functional groups are the things that are detected in this IR spectrum. So these are the various organic functional groups that would be detected. Okay, so just keep an eye on these. We have the carbon oxygen single bond, carbon oxygen double bond, carbon carbon single, carbon carbon double, carbon carbon triple, carbon nitrogen single, carbon nitrogen triple, carbon hydrogen single, and carbon halogen single. And then we have the ester linkage. So these are just the various examples. There are many more, and these are what are basically represented on this IR spectrum, and it will start to make sense in a later slide. Okay, now all of this entire thing, how they are detected because of a certain phenomena called bond vibration. Okay, now basically what happens is that these organic compounds have these functional groups, right? And these functional groups undergo bond vibration, which leads to the detection of energy being released, or percentage transmittance or percentage absorbance being detected. Okay, now bond vibration is of two types. There is either bond stretching or there is bond bending. Bond stretching means that if this is your bond, right, this is an example of a bond, it would stretch either way. Like, you know how you have a spring can be stretched either way. It's sort of like that. Okay, so this is bond stretching, and this basically leads to energy being absorbed and released. Okay, so this entire vibration of backwards and forwards movement leads to bond stretching. Now what is bond bending? Bond bending is basically that if you have these two bonds, they will bend. Okay, and that basically leads to these two bonds stretching. So it can happen simultaneously. Bond bending and bond stretching can happen simultaneously, and that leads to energy or wavelengths being absorbed or transmitted. Okay, and this entire phenomena of bond vibration leads to vibrations occurring in different ways involving different amounts of energies. So if you have a carbon oxygen bond, that will vibrate at a different proportion. If you have a carbon nitrogen triple bond, that will vibrate at a different proportion, and that will lead to a different release of energy, a different release amount of release of energy. Okay, so that is why every functional group has their own specific energy that is released. Okay, now in the next video we will be discussing the IR spectrum and how it looks. Thank you.